So now we understand a little bit about the normal curve. We want to look at some way to understand scores. And here I have a score for someone who took the ACT, and they took the ACT and got a composite score of 26. Now, 26, if you know anything about the ACT, 26 is a pretty good score. It's not bad at all. But if we want to know really, if we didn't know anything about the ACT and we wanted to have some idea of what does 26 mean? Is it 26 out of 5,000? Is it 26 out of 27? It's going to look really, really different. And if we don't have any way of understanding what the score of 26 means, we can actually plug that into the curve and see where it falls compared to everybody else. So, in order for us to do that, we need a couple of pieces of information. And let's see, where is my... Okay, we need a couple of pieces of information. So in order to convert a raw score of 26 to a standard score, the first score that we would like to convert it to is a z-score, because that's so useful. So the formula for converting a raw score to a z-score is very, very simple. We take the raw score, which in this case is 26, subtract the mean, and then divide by the standard deviation. It's always the formula for a z-score. So we actually have, I think I downloaded the wrong table, but for our purposes, the purposes of demonstration, it doesn't make any difference. So this table, I thought this was 2006, so I'm using the 2006 table, but we're going to pretend it's 2011. All right, so according to this is from the ACT website. It says that the mean or average for 2006, which is the year I thought we were talking about, was 21.1. And for that year, the standard deviation was 4.8. So those are the two numbers that we need in order to convert a raw score of 26 to a standard score. We're going to plug that into this formula. So that would mean our raw score was 26, right? 26 minus the mean, which we said was 21.1. That gives us 4.9. And we divide that by the standard deviation, which in our little table a while ago was 4.8. And that gives us a z-score. So here, z would equal, right here, 1.02. Now, what exactly does that mean? So I'm going to flip back over, hopefully. Maybe, hopefully. All right, I'm going to flip back over here to our whiteboard, because if we have a z-score, what did we say it was? 1.03. We have a z-score of 1.03. Z equals. We need to figure out where that lies. Let me get rid of this stuff here. Where that lies on our curve. So a z-score of 1.03, if this is one standard deviation above the mean, this is the one right here. So it's going to be about, almost exactly on this line, or just the slightest hair to the right. Because we're at 1, here's 1, plus we've got the 0.03, which is really negligible. So it's just to the heavy side of 1 standard deviation above the mean. And this is positive, it's not negative. That becomes really okay. All right. So now we have a better idea of where this person scored compared to all the other individuals. Additionally, if we want to, we can get some idea of what that means. If we're at 1 standard deviation above the mean, and we look at the percentages down here underneath, I'm going to do something besides orange because we've already got orange, right? So our cumulative percentage goes from the left side to the right side, and it just keeps adding all of this up here together. So if we are at 1 standard deviation, what that means is that this person who is at 1 standard deviation scored the same as or better than 84.1% of the people who took this ACT in this year. It also would mean that they were in the, looks like 80, in the 80, about the 85th percentile here under percentiles. So about right there. We already know their z-score because we've got the z-score up here, 1.03, which is right here. Their t-score is going to be at 60. Now we can figure the t-score out mathematically, but if we look at this, we can eyeball it and say, oh yeah, their t-score is going to be around 60. It's very useful, I think, to look at both the z-score and the percentile, because that gives us a lot of information. Okay, so I'm going to flip back over here for just a second. And we want to look at t-score. So t-score, we can do t-score. Let's clear that off. The t-score is the z-score, which was 1.03 times 10 plus 50. Okay, so our z-score is 60.3. Now let's look back over here and see, let's minimize that. So when we were looking at our t-score, we said it's going to be right here. So it's right at the 60 mark. It's actually 60 point, is it 3 or 03? Oops, I didn't want to do that. Now let's see, 60 point, technology, 60.3. Okay, 60.3. So mathematically, we work it out, it's very precise. We can eyeball it very easily, but just by looking at the normal curve and all of the standard scores. But if we want to do it mathematically, here it is. This is exactly it. All right, so I hope that helps you understand how you can convert a raw score to a standard score and not just z-scores, but also t-scores.